Hey there, welcome back to the channel. I was sitting outside last night just looking up at the stars and I started thinking about time. Not like, oh man, I'm running late for work time, but real time, deep time. The kind of time that makes your head spin when you try to wrap your brain around it. And I had this thought that absolutely blew my mind. What if I told you that every single thing you've ever learned about in history class, every king and queen, every war, every love story, every invention, every building, every book, every moment that humans have ever written down, happened in less than the last 14 seconds of a single year? And what if I told you that this year represents the entire history of the universe, from the very first moment of the Big Bang, all the way to you sitting there watching this video right now? Before we dive into this absolutely mind-bending journey, do me a favor. If you're fascinated by this kind of perspective-shifting content that makes you see your place in the universe differently, hit that like button. It really helps the channel grow, and more importantly, it tells me you want to see more videos like this. And if you haven't subscribed yet, what are you waiting for? We're about to go on a trip through 13.8 billion years together, and trust me, you're going to want to be part of this community. While you're at it, drop a comment below and tell me where you're watching from and what time it is there. I love seeing how this channel connects people across different time zones and continents, especially when we're about to talk about how tiny our human concept of time really is. Now, let's set the stage for something truly extraordinary. The cosmic calendar is a way of understanding time that was made famous by the brilliant astronomer Carl Sagan, though the idea has been adapted and expanded by many scientists since. Here's how it works. We take the entire 13.8 billion year history of our universe, and we squeeze it down into the framework of a single calendar year. January 1st at midnight is the Big Bang, the very beginning of everything as we know it. December 31st at midnight is right now, this very moment. Every month represents about 1.15 billion years. Each day represents roughly 38 million years. Each hour equals about 1.6 million years. Each minute is about 26,000 years. And each second represents about 434 years of real cosmic time. Let that sink in for a moment. In the time it takes me to say just this one sentence, we've covered more time than has passed since Shakespeare wrote his plays. The universe begins on January 1st, at exactly midnight, but here's where things get wild right away. The first second of January 1st, that single tick of the cosmic clock, contains more action and transformation than the rest of the entire year combined. In that first fraction of a second, everything that would become everything else comes into being. Scientists call this the Planck epoch, and it lasts from zero time all the way to about 10 to the negative 43 seconds. I know, that's a number so small it's hard to even say out loud. It's a decimal point followed by 42 zeros and then a 1. That is how much time passes before the fundamental forces of nature even separate from each other. At this moment, the entire universe is smaller than a single atom, hotter than anything you could possibly imagine, and all the forces that govern reality, gravity, electromagnetism, the strong nuclear force, the weak nuclear force, they're all merged together into one unified force. Think about that. The gravity that holds you to your chair right now, the electromagnetic force that lets you see your screen, the nuclear forces that hold atoms together, they were all the exact same thing. It's like having a single superpower that suddenly splits into all the different superheroes you know. Then we move into the grand unification epoch, which runs from 10 to the negative 43 seconds to 10 to the negative 36 seconds. Gravity decides it's time to be its own thing and splits off from the other forces. The universe is still unimaginably hot, trillions of degrees, but now gravity is working independently, starting to shape the cosmos even as it's still being born. This is like the foundation of a house being poured, while the architect is still drawing the blueprints. Next comes the inflationary epoch, from 10 to the negative 36 seconds to 10 to the negative 32nd seconds. This is when the universe does something that still makes scientists' jaws drop. It expands exponentially, faster than the speed of light. Now, don't worry about that breaking any physics rules. Space itself can expand faster than light. It just can't carry information faster than light. In this tiny fraction of a moment, the universe goes from being smaller than an atom to being about the size of a grapefruit. That's like a grain of sand suddenly inflating to the size of the entire observable universe in the blink of an eye. This inflation smooths out the universe, making it look pretty much the same in all directions, which is why when we look out at the cosmos today, it appears so uniform. Those tiny quantum fluctuations that happen during this period get stretched out to cosmic scales, and they become the seeds of all the galaxies, stars, and eventually planets that will ever exist. Every structure you see in the night sky today started as a microscopic wobble in the fabric of space-time during this fraction of a second on January 1st. Then we have the electroweak epoch, from 10 to the negative 36 seconds to 10 to the negative 12 seconds. The strong nuclear force splits off from the electroweak force, leaving us with three distinct forces: gravity, the strong force, and the electroweak force. Particles are being created and destroyed in a seething cauldron of energy. This is where the Higgs field starts doing its important work, giving mass to certain particles. Without this moment, nothing would have mass, and the universe would just be a bunch of massless particles zipping around at the speed of light forever. The Higgs field is like cosmic molasses that slows some particles down and gives them the property we call mass. It's not actually molasses, of course, but it's a helpful way to think about it. The quark epoch runs from 10 to the negative 12th seconds to 10 to the negative 6th seconds. The universe has cooled down to a mere 10 quadrillion degrees. Quarks, electrons, and neutrinos are forming in huge numbers. The four fundamental forces now have the forms we recognize today. Quarks and antiquarks are constantly annihilating each other when they meet, but thanks to a tiny asymmetry, about one extra quark for every billion quark-antiquark pairs, some quarks survive. This tiny imbalance, this 1 in a billion preference for matter over antimatter, is why you exist. If the universe had been perfectly balanced between matter and antimatter, they would have completely annihilated each other, leaving nothing but pure energy. But we got that tiny extra bit of matter, and that became everything: all the stars, all the planets, all the galaxies, and eventually you. The Hadron epoch runs from 10 to the negative 6th seconds to about 1 second after the Big Bang. The universe has cooled enough that quarks can start binding together to form protons and neutrons, the building blocks of atomic nuclei. This is like watching Legos suddenly decide to stick together after being separate pieces. The temperature is still about 1 billion degrees, but now we're getting the first stable particles that will eventually become atoms. Think about this. Everything that makes up your body, the carbon in your cells, the calcium in your bones, the iron in your blood, all of it was forged from these first protons and neutrons that formed in this single second on January 1st. At about 1 second after midnight on January 1st, we get the lepton epoch. The universe is now cool enough that leptons, electrons, muons, tau particles, and their associated neutrinos can exist without immediately being destroyed. Photons are everywhere, constantly colliding with matter, keeping everything in a sort of thermal equilibrium where radiation and matter are constantly exchanging energy. The universe is still opaque, like being inside a star. Light can't travel far without hitting something. Around 10 seconds after midnight, we're in the photon epoch. The universe is filled with a plasma of nuclei, electrons, and photons. But something important is happening. The temperature is dropping fast. From 10 seconds all the way to about 380,000 years, this plasma state persists. The universe is like a hot, dense fog where photons can't travel freely. If you could be there, you wouldn't be able to see your hand in front of your face, because the photons of light would bounce off all the free electrons before they could reach your eyes. Now we jump forward to about 380,000 years after the Big Bang. On our cosmic calendar, this is still January 1st, but it's about 14 minutes past midnight. This is when the universe has cooled to about 3,000 degrees Kelvin, which is cool enough for electrons to combine with protons to form neutral hydrogen atoms. This process is called recombination, though it's really the first time electrons and protons have combined, not a recombination. When this happens, the universe becomes transparent for the first time. All those photons that have been bouncing around can now travel freely through space. This light, released 14 minutes into our cosmic year, is what we see today as the cosmic microwave background radiation. When we point our most sensitive telescopes at the darkest parts of the sky, we see this faint afterglow of the Big Bang, cooled over 13.8 billion years from 3,000 degrees to just 2.7 degrees above absolute zero. It's the oldest light in the universe, and it carries a baby picture of the cosmos when it was just 14 minutes old. From 380,000 years to about 150 million years after the Big Bang, we have what scientists call the Dark Ages. On our cosmic calendar, this stretches from about 14 minutes past midnight on January 1st all the way to about January 6th. During this period, the universe is transparent but dark. There are no stars yet, no galaxies, just cooling clouds of hydrogen and helium gas and dark matter. Dark matter, which we can't see directly but can detect through its gravitational effects, is already starting to clump together under its own gravity. These clumps form the gravitational scaffolding that ordinary matter will eventually fall into. Think of it as invisible skeletons that will later be fleshed out with stars and galaxies. The first stars begin to form around 100 to 200 million years after the Big Bang, which would be roughly January 6th or 7th on our calendar. These are called population III stars, and they're nothing like the stars we see today. They're massive, hundreds of times the mass of our sun, and made only of hydrogen and helium, with no heavier elements at all. They burn hot and fast, living for only a few million years before exploding as supernovae. In their deaths, they seed the universe with the first heavy elements: carbon, oxygen, nitrogen, iron, all the stuff that planets and eventually life will be made of. These first stars are the ultimate alchemists, turning simple hydrogen into the complex periodic table of elements. By about 1 billion years after the Big Bang, which is late January on our cosmic calendar, the first galaxies are forming. Small proto-galaxies merge together to form larger ones, including the ancestors of our own Milky Way. Reionization is in full swing, the process where the ultraviolet radiation from these early stars and galaxies ionizes the neutral hydrogen gas that fills the universe, clearing away the cosmic fog. The universe transitions from dark and neutral to bright and ionized. The Milky Way galaxy, our home, begins to form around 11 billion years ago. On the cosmic calendar, this is about March 15th. It starts as a small collection of stars and gas that merges with other small galaxies over hundreds of millions of years. The familiar spiral structure that we see in pictures of the Milky Way doesn't form until later, but the basic building blocks are falling into place in mid-March of our cosmic year. Think about that. Our galaxy is already about 8.5 months old by the time we get to the present moment. Nothing particularly interesting happens for the next several months on our cosmic calendar. The universe continues to expand, galaxies continue to form and merge, stars are born and die in cycles. But life as we know it hasn't started yet. The universe is still too violent, too filled with radiation, too poor in heavy elements. But all that is about to change. Fast forward all the way to early September. It's September 6th on our cosmic calendar, about 4.6 billion years ago in real time. This is when our solar system forms from a cloud of gas and dust in a spiral arm of the Milky Way. A nearby supernova, the explosion of a dying star, sends shock waves through this cloud, causing it to collapse under its own gravity. As it collapses, it spins faster and flattens into a disk. Most of the mass falls into the center, where the pressure and temperature become so intense that nuclear fusion ignites, and our sun is born. The remaining material in the disk, about 0.1% of the original cloud, forms the planets, moons, asteroids, and comets. The Earth forms around September 14th, about 4.5 billion years ago. It starts as dust grains that stick together, growing into pebbles, then boulders, then planetesimals, then protoplanets, and finally a full-sized planet. The early Earth is a hellish world, molten rock everywhere, constant bombardment from asteroids and comets, no atmosphere to speak of. But it's also growing heavier as it accumulates material, and its gravity is strong enough to hold onto gases. The Moon forms very shortly after Earth, probably on September 16th, when a Mars-sized protoplanet named Theia crashes into the early Earth. This catastrophic impact melts both bodies and splashes a huge amount of debris into orbit around Earth. This debris quickly coalesces to form the Moon. This event is crucial for life later on. The Moon stabilizes Earth's rotation, prevents extreme wobbling that would make climate chaotic, and creates tides that may have helped life get started in tidal pools. Life on Earth begins sometime around September 21st to September 30th. We're not exactly sure when, because the earliest life was microscopic and didn't leave obvious fossils. It might have started around hydrothermal vents on the ocean floor, where chemical energy from the Earth's interior provided power for simple chemical reactions. Or maybe it started in tidal pools where lightning and ultraviolet radiation drove chemical synthesis. However it happened, by the end of September on our cosmic calendar, we have the first simple cells, prokaryotes, living on Earth. These are incredibly simple compared to modern life, just little bags of chemicals that can copy themselves. But they're revolutionary. They're the first things we would recognize as alive. October on our cosmic calendar sees the development of photosynthesis. Around October 5th, some bacteria figure out how to capture sunlight and use it to make food, releasing oxygen as a waste product. At first, this oxygen is absorbed by iron in the oceans and rocks, rusting them and turning them red. But eventually, around October 25th, the oxygen starts to build up in the atmosphere. This is both wonderful and terrible. Wonderful because oxygen is great for complex life later on. Terrible because oxygen is poisonous to the early life that evolved without it. This is Earth's first mass extinction, caused by the waste product of photosynthetic bacteria. The bacteria that can't handle oxygen die off or retreat to oxygen-free environments, while new forms of life that can use oxygen begin to evolve. November is a quiet month on our cosmic calendar. The atmosphere is now oxygen-rich. The continents are starting to form and move around. Plate tectonics is up and running. Simple cells continue to dominate life. There's not much visible action, but important changes are happening at the molecular level. Cells are getting more complex, developing better ways to process energy and replicate their genetic material. December 1st arrives, and we're now in the final month of our cosmic year. Multicellular life finally evolves around December 5th. For the first 3.5 billion years of Earth's history, life was microscopic and single-celled. But now, cells figure out how to work together, specializing in different tasks. This is a huge leap. It's like going from solo artists to a symphony orchestra. Suddenly you can have cells that specialize in feeding, others in reproduction, others in movement. This opens up possibilities for much larger, more complex organisms. The Cambrian explosion happens around December 17th. This is one of the most important events in the history of life. Over a period of just a few million years, which is incredibly fast in evolutionary terms, almost all the major animal groups we know today appear in the fossil record. Trilobites, those iconic ancient sea creatures with the segmented bodies, show up. So do the first vertebrates, our ancestors. Before this, the fossil record shows simple worm-like creatures. After this, we have animals with shells, eyes, legs, mouths, claws. It's like someone flipped a switch and suddenly life got really interesting and diverse. Some scientists think this explosion of diversity was triggered by the evolution of eyes. Once predators could see their prey, An arms race began, leading to all sorts of defensive and offensive adaptations. December 18th brings the first fish with jaws. Before this, fish were simple filter feeders without jaws like modern lampreys. But jaws are a game changer. They let animals grab and process food more efficiently. If you have a jaw, you're not limited to just filter feeding. You can become a predator. And if you're being hunted, you need to evolve defenses. This predator-prey dynamic drives evolution forward. Plants start colonizing land around December 20th. This is huge because before this, all life was in the oceans. Land is a harsh environment, it's dry. There's intense ultraviolet radiation from the sun, and there's no buoyancy to support your weight. But plants that can survive on land have access to sunlight that aquatic plants are missing out on. They develop waxy coatings to prevent water loss and root systems to extract water and nutrients from soil. Once plants are established on land, they create new ecosystems for animals to move into. Amphibians crawl onto land around December 22nd. These are the first vertebrates to venture out of the water, but they still need to return to water to lay their eggs. They're not fully committed to land life yet. They're like the commuters of the ancient world, splitting their time between two environments. Their lungs let them breathe air, but their thin skin means they can dry out quickly, so they can't stray far from water. The first reptiles appear on December 23rd. Reptiles are the first vertebrates that can lay eggs on land. Their eggs have protective shells and internal membranes that let the embryo develop in a watery environment even though the egg is on dry land. This is a huge innovation. It means reptiles can colonize the interior of continents, not just the coasts. This is when life truly conquers land. Dinosaurs arrive on December 24th, Christmas Eve. For the next week or so on our cosmic calendar, they will rule the Earth. Dinosaurs are incredibly successful. They dominate every continent, evolve into thousands of species from tiny chicken-sized creatures to the massive long-necked sauropods. They thrive for about 165 million years in real time, which translates to about 7 days on our cosmic calendar. December 25th, Christmas Day, sees the first mammals. Mammals evolved from a group of reptiles called synapsids, but they stay small and nocturnal for most of the age of dinosaurs. They're the scrappy underdogs of the Mesozoic era, scurrying around in the shadows while dinosaurs rule the day. Their warm-blooded metabolism and fur let them stay active at night when it's cooler, and they develop better brains and more complex behavior. But they won't get their chance to shine until the dinosaurs leave the stage. Birds evolve around December 26th. Birds are actually dinosaurs. They're the surviving descendants of a group of carnivorous dinosaurs called theropods. So when we say dinosaurs went extinct, we're not being entirely accurate. The non-avian dinosaurs died out, but the avian dinosaurs, birds, made it through and are still with us today. Every time you see a sparrow or a chicken, you're looking at a modern dinosaur. The first flowering plants appear on December 28th. This might not sound as exciting as dinosaurs, but it's actually revolutionary. Flowering plants reproduce using pollination, often by insects. This creates a new type of relationship between species, mutualism, where both partners benefit. Flowers provide nectar. Insects provide pollination. This drives the evolution of both groups and creates the ecosystems we recognize today. Now we arrive at December 30th, the day before the last day of our cosmic year. This is a momentous day. At about 10 in the morning on December 30th, a massive asteroid about 6 miles across slams into what is now the Yucatan Peninsula in Mexico. The impact releases energy equivalent to billions of atomic bombs, creates tsunamis hundreds of feet high, and throws so much dust into the atmosphere that the sun is blocked out for months or even years. Temperatures plummet, plants stop photosynthesizing, and food chains collapse. The non-avian dinosaurs, which have ruled Earth for 7 days on our calendar, can't adapt to these sudden changes and go extinct. This catastrophe clears the stage for the mammals, which have been waiting in the wings for their chance. December 30th continues with the rise of mammals. Without dinosaurs dominating the daytime, mammals can now evolve to fill all the empty ecological niches. Some become large herbivores, others become predators, and others take to the trees or the air. The diversity of mammals explodes, and this sets the stage for our own appearance. Now we reach December 31st. This is the most important day in the entire cosmic calendar, at least from our perspective. It's the day that includes everything we think of as important, all of human history, all of our evolutionary ancestors, everything that makes us human. Let's zoom in on this final day, because this is where things get absolutely crazy in terms of how compressed time becomes. The morning of December 31st, very early, around 1:30 in the morning, we see the first primates. These are small, tree-dwelling mammals with grasping hands and forward-facing eyes that give them good depth perception. They're not much to look at yet, but they have the basic body plan, flexible limbs, dexterous hands, large brains relative to body size, that will eventually lead to us. The first hominids, our direct ancestors after they split from the other apes, appear around 10:30 at night on December 31st. That's 10:30 p.m. on the very last day of the cosmic year. These early hominids, like Australopithecus, walk upright on two legs but still have small brains. They use simple stone tools, but they're basically just modified rocks, sharp flakes broken off larger stones. There's no real shaping or planning involved yet. Widespread use of more sophisticated stone tools happens around 11 o'clock at night on December 31st. These are tools that are deliberately shaped, with specific forms for specific tasks, hand axes for chopping, sharp flakes for cutting. This represents a quantum leap in cognitive ability. The hominids making these tools have to be able to picture in their minds what they want the final tool to look like, and then execute a series of precise strikes to achieve that shape. This requires planning, abstract thought, and the ability to hold an image in your mind that doesn't yet exist in reality. These are uniquely human traits starting to emerge. The domestication of fire happens around 11:46 at night on December 31st. Fire is transformative. It provides warmth, letting hominids survive in cold climates. It provides light, extending the day and protecting against predators. It makes food safer to eat and easier to digest, which means more calories can go to feeding a growing brain. Some anthropologists think the control of fire was the key innovation that allowed brain size to increase dramatically. Once you can cook your food, you don't need such a large gut to process raw plant material, and the energy saved can be redirected to brain tissue. Fire also becomes a tool for shaping the environment, using fire to clear land, to drive game, to create new growth. Symbolic language develops around 11:52 at night on December 31st. This is arguably the most important development in all of human evolution. Language lets us share information about things that aren't present. We can talk about yesterday's hunt or plan tomorrow's gathering. We can share abstract concepts, tell stories, transmit culture. Without language, each generation has to figure everything out from scratch. With language, knowledge accumulates. A discovery made by one person can be shared with the entire group and passed down to children. This is when culture truly begins, separate from biology. Anatomically modern humans, Homo sapiens, appear around 11:54 at night on December 31st. These are humans that look like us, with the same brain size, the same body proportions. They have language, they make complex tools, they have culture, but they're still living as hunter-gatherers. They haven't invented agriculture, they haven't built cities, they haven't developed writing. All of that is still to come in the last few minutes and seconds of our cosmic year. The most recent glacial period begins around 11:56 at night. Ice sheets advance from the poles, covering much of North America and Europe. Sea levels drop, revealing land bridges. This forces human populations to move, to adapt, to develop new technologies for surviving in cold climates. It also creates the Bering Land Bridge between Siberia and Alaska, allowing humans to migrate into the Americas for the first time. Seafarers settle Australia around 1158 at night. This is remarkable because it means humans have figured out how to build boats and navigate open water. Australia is separated from Asia by deep ocean channels, even during periods of low sea level. To get there, humans must have built seaworthy vessels and had the navigational skills to make intentional voyages. This shows sophisticated planning and technology. Extensive cave painting appears around 1159 at night. This is the first clear evidence of symbolic thinking, of art, of humans creating images that represent things in the world. The cave paintings at Lascaux and Altamira show animals, humans, and abstract symbols. These aren't just random doodles, they're deliberate creations, requiring planning, preparation of pigments, and the development of artistic techniques. They suggest that humans are thinking about their place in the world, about the animals they hunt, about the mysteries of existence. The invention of agriculture happens at 1159 and 20 seconds. This is the single most important event in human history. For the first time, humans stop being hunter-gatherers who move around to find food and become farmers who stay in one place and grow their food. This change from nomadic to settled life is revolutionary. It leads to permanent villages, population growth, specialization of labor. Not everyone needs to be a farmer anymore, so some people can become toolmakers, priests, artists, leaders. It creates surplus food, which can be stored and traded. It fundamentally changes the relationship between humans and the environment. And it all happens in the last 40 seconds of our cosmic year. Neolithic civilization and the first cities appear at 1159 and 35 seconds. Once you have agriculture and surplus food, you can support larger populations in one place. People build permanent houses, then villages, then towns, then cities. The first cities like Jericho and Saddle-Huruk appear in the Middle East. They have walls, they have specialized buildings, they have social hierarchies. This is the birth of civilization as we know it. The first dynasties in Sumer, Ebla, and Egypt develop at 1159 and 50 seconds. This is the beginning of recorded history. Humans invent writing to keep track of trade, to record laws, to tell stories that last longer than oral tradition. Writing is like external memory. It lets us store information outside our brains, in clay tablets and later paper. This means knowledge can accumulate across generations without being lost to the faulty memory of storytellers. The development of astronomy also happens around this time. People start systematically observing the stars, tracking the movements of planets, noticing patterns that will eventually become the foundation of science. The invention of the alphabet and the rise of the Akkadian Empire happen at 1159 and 51 seconds. The alphabet is a huge improvement over earlier writing systems like cuneiform or hieroglyphics. Instead of needing thousands of symbols, you only need a few dozen letters that can be combined to represent any word. This makes literacy much more accessible. You don't need to spend years memorizing thousands of symbols. You just need to learn the letters and how they combine. This democratizes knowledge to some extent. The Code of Hammurabi in Babylon and the Middle Kingdom in Egypt happen at 1159 and 52 seconds. Written law codes are another huge step forward. Instead of justice being arbitrary or based on the whim of a ruler, laws are written down and applied, more or less, equally to everyone. This creates predictability in society, which is essential for complex trade and social organization. The Bronze Age begins and writing is further developed at 1159 and 53 seconds. Bronze, an alloy of copper and tin, is stronger than pure copper, making better tools and weapons. Bronze tools increase agricultural productivity. Bronze weapons change warfare. The combination of better technology and written records accelerates the pace of change. Between 1159 and 54 seconds and 1159 and 56 seconds, we see the rise and fall of major ancient civilizations. The Trojan War, the founding of Rome, ancient Greece, the birth of Buddha, the rise of Christianity, the fall of Rome, the birth of Islam. All of these world-changing events happen in the last 6 seconds of our cosmic year. Think about that. The entire rise and fall of the Roman Empire, which lasted over 1,000 years in real time and seemed eternal to the people living through it, occupies less than 1 second on the cosmic calendar. The Dark Ages in Europe happen around 1159 and 57 seconds. After the fall of Rome, much knowledge is lost in Western Europe, but in other parts of the world, the Islamic world, China, India, science and culture flourish. The concept of zero is invented in Indian mathematics, which revolutionizes arithmetic and makes modern mathematics possible. Gunpowder is invented in China. The Islamic Golden Age preserves and builds upon ancient Greek knowledge, laying the groundwork for the Renaissance. The Renaissance and the voyages of discovery happen at 1159 and 58 seconds. Europeans rediscover classical knowledge and develop new ways of thinking. The printing press is invented, making books cheap and widely available. Knowledge starts to spread faster than ever before. Explorers set out across the oceans, mapping the world and connecting previously isolated civilizations. This creates the first truly global network of trade and communication. The scientific revolution happens at 1159 and 59 seconds. Humans invent the scientific method, a systematic way of asking questions about nature and testing hypotheses through experiment and observation. This is arguably the most powerful tool humans have ever developed. With it, we figure out the laws of motion, the nature of light, the structure of the solar system. We invent the telescope and the microscope, opening up new worlds both vast and tiny. All of modern science, physics, chemistry, biology, astronomy begins in this single second. The Industrial Revolution also happens at 1159 and 59 seconds. Humans harness steam power, then electricity, then internal combustion. We build factories, railroads, steamships. We extract coal and oil from the ground and burn them for energy. This transforms society completely. People move from farms to cities. Mass production makes goods cheap and available. New forms of transportation and communication shrink the world. The invention of the airplane and the car happen at 1159 and 59.8 seconds, 8/10 of the way through the final second. In just the last 2/10 of a second, we develop nuclear weapons, land on the moon, create the computer revolution, sequence the human genome, connect the world through the internet, and develop social media. The average human lifespan of about 70 years equates to about 0.16 seconds on the cosmic calendar. Your entire life, all your memories, all your experiences, everything you've ever learned or loved or dreamed, fits into less than 1/5 of a second in the grand timeline of the cosmos. The moment you were born and the moment you will die are practically the same instant on this scale. And here we are, right now, at midnight on December 31st, at the very end of our cosmic year. You are listening to this voice, understanding these words, reflecting on your place in this vast timeline. Every thought you've ever had, every emotion you've ever felt has happened in this final fraction of a second. Now take a breath and let that sink in. Because this perspective, this cosmic calendar, it's not just a clever way to visualize big numbers. It's a tool for understanding something profound about our existence. When we see how tiny our moment is in the grand scheme of things, it can be humbling, maybe even a little scary. But it's also empowering. Because if we are the universe's way of knowing itself, as Carl Sagan famously said, then all of this cosmic history has been leading up to this moment, right now, where conscious beings can look back and understand the story. Think about everything that had to happen for you to be here. That 1 in a billion asymmetry between matter and antimatter in the first second of January 1st. The exact rate of inflation that made the universe just right for stars to form. The particular supernova that seeded our solar system with heavy elements. The asteroid that wiped out the dinosaurs and gave mammals their chance. The series of climate changes that forced our ancestors to adapt and evolve. the invention of agriculture that allowed civilization to develop, the scientific method that lets us understand all of this. Every step along the way, if things had been just slightly different, you wouldn't be here. The universe would still exist, but it wouldn't have this moment of self-awareness. It wouldn't have anyone to appreciate its beauty and complexity. And here's something else to think about. The universe is still going. Our cosmic calendar is just the history so far. We're at midnight on December 31st, but what about next year? What about the future? The universe is about 13.8 billion years old now, but it's going to keep going for trillions of years. The star formation will eventually slow down as galaxies use up their gas. The longest-lived stars will burn for trillions of years. The universe will keep expanding, and eventually all the galaxies will be so far apart that they'll be invisible to each other. But that's an almost incomprehensibly long time from now. In the much nearer term, meaning the next few seconds on our cosmic calendar, we face some critical challenges. We have developed the power to understand the cosmos, but also the power to destroy ourselves. Nuclear weapons, climate change, artificial intelligence, pandemics, these are all problems we created in the last fraction of a second of cosmic time. And we need to solve them in the next fraction of a second. Or this brief moment of consciousness that the universe has achieved might be just that, a brief moment that flickers out. But I'm optimistic. Look at what we've accomplished in just a fraction of a second. We've gone from living in caves to walking on the moon. We've figured out the laws of nature that govern everything from the smallest particles to the largest galaxies. We've created art, music, literature, science. We've built a global civilization that, despite all its flaws, is capable of incredible cooperation and achievement. If we can do all that in 0.16 seconds, imagine what we could do with a whole second, or a minute, or even an hour of cosmic time. The potential is staggering. Now here's what I want you to do. I want you to take this cosmic perspective with you in your daily life. When you're feeling stressed about a deadline, or upset about a disagreement, or worried about something that seems huge in the moment, remember the cosmic calendar. Remember that in the grand timeline of the universe, this moment is infinitesimal. That doesn't mean your problems aren't real or important, they are, but it puts them in perspective. It reminds us that we have the privilege of being conscious, of being able to experience this beautiful, vast, mysterious universe. It reminds us to be grateful for this brief moment we have. And it reminds us of our responsibility. We are, as far as we know, the universe's only way of understanding itself. We are the cosmos, condensed into conscious form, looking back at its own history and marveling at its own existence. That's an incredible gift, and it comes with the responsibility to protect this consciousness, to nurture it, to spread it if we can. Maybe one day, if we solve the challenges facing us, we'll be able to ensure that consciousness survives and spreads beyond Earth, that the universe's self-awareness doesn't end with us. If you found this journey through cosmic time as mind-expanding as I did, please take a moment to hit that like button. It really does make a huge difference in helping this channel reach more people who might need this cosmic perspective. And if you're new here, subscribe and ring that notification bell so you don't miss our future explorations of reality. We've got videos planned about quantum mechanics, the nature of consciousness, the search for alien life, and all the biggest questions we can think of. This channel is all about giving you tools to understand your place in the cosmos, and I can't wait to share more of these mind-bending ideas with you. Also, please share this video with someone who needs a little perspective in their life. Maybe someone who's feeling overwhelmed, or someone who loves thinking about the big questions. And drop a comment below, tell me where you're watching from and what time it is there. I read every single comment, and I love seeing how this community spans the globe. We might be separated by time zones and continents, but we're all sharing this same moment in cosmic time. We're all here together at midnight on December 31st, looking back at the year that was and wondering about the year to come. Before I sign off, I want to leave you with one final thought. In the last second of our cosmic year, we develop science. We learn to ask questions, to seek evidence, to test our ideas against reality. We learn that the universe is comprehensible, that we can figure it out. That might be the most amazing discovery of all, not just that we exist, but that we can understand why we exist. That the same laws of physics that shaped the galaxies also shaped our brains, allowing us to contemplate those galaxies. So as you go about your day, remember you are the universe experiencing itself. You are the product of 13.8 billion years of cosmic evolution. Every atom in your body was forged in stars that lived and died long before our sun was born. You are, quite literally, stardust. But you're also conscious stardust, which is pretty amazing when you think about it. You can think, you can feel, you can love, you can wonder. And right now, you can look back at the entire history of the cosmos and understand your place in it. That's truly incredible. So, thank you for spending this time with me, thinking about the biggest story there is, the story of everything. I hope this cosmic perspective stays with you, that it brings you both humility and empowerment, that it reminds you both how small we are and how precious consciousness is. Good night wherever you are in the world. Sleep well under those stars, knowing that you are part of their story just as they're part of yours. And remember, every second is 434 years of cosmic time. Make them count.